Welcome to Spring LIB.
Here we have a circular plate that's supported by two bearings, as shown. So again, I'm not going to try to reproduce the figure there, but you can look at it in the book. And so the plate rotates about the rod joining A and B. So he kind of rotates at this about this inclined axis, um, and it rotates at a constant angular velocity of this value here. And we know that we're told that the radius is of the disc is 120 millimeters. So in this case, we want to figure out what the angular velocity and the angular acceleration of a point E, which is along, at the edge of the disc. Okay. Knowing that this is directed to the right. Okay, so again, we need that the velocity is directed to the right. Basically, it says that, tells us which direction that this is going to be positive. If we get a vector from B to A. Okay, so if we take a vector from B to A, we use the right hand rule. This is a positive value. Okay. Now, so here we write the vector from B to A. Okay, so we can either take it from the origin, the two vectors from the origin, and take the difference. So this is a vector that points from B to A, and it's not a unit vector. It has a magnitude, and this is given in meters. And then we can figure out a vector from A to E, or from E to A. And again, we're kind of using A as our reference here. And so now we have that vector here, and given in terms of meters. Okay, so again, that's at this instant in time that's shown in the figure. So this is the axis about which it's rotating. So we need to make a unit vector out of that, and we can do that by dividing this by its magnitude. So we get this unit vector. That gives us the angular velocity vector. The angular acceleration vector is 0 because we know that the magnitude of the angular acceleration is 0, as given in the problem. Now the velocity at point E, okay, is the angular velocity crossed with the position vector of point E with respect to A. Okay, so again, we're kind of using A as our basis here. Now we can just do this cross product, and we get this angular velocity here for point E. And that, I think you can look at that and kind of imagine this thing swinging around. I guess it would be, if you look down the z-axis, it would be counterclockwise, or down from the positive z-axis down towards. And you can say, well, okay, the velocity in the x direction, yeah, that seems like it should be positive. In the y direction, yeah, seems like it should be positive. In the z direction, it's a little hard to say, but that makes somewhat sense that it's actually, moving forward in the z direction at that point because of the incline of the axis. Now, if the axis were just the rotation axis were along the z-axis, then obviously at this point this term would be 0. And you could go back, you could go through and check that, make sure that was the case. Now, the angular acceleration, or the acceleration at point E, is given by this expression. Again, angular acceleration is 0, so this cross product goes away. We have the angular velocity vector, and we have the velocity vector at that point. And so we can do this cross product, and again, we get this term here. And we can think about, look at this and say, okay, does this make sense? It kind of does. It makes sense that this is negative. Centrifugal acceleration is going to pull that in. Again, if it was, the other terms are a little bit weird because of just because of the inclined axis. And so again, it's hard to really justify these. I mean, you can kind of think about it a little bit, that at a given point like this, the angular velocity, the angular acceleration in the j direction, again, it's a little hard to explain why that is the case, and the same way in this, but it's really that inclined axis that it's really hard to picture exactly what's going on there. So again, using your intuition on these to just kind of intuitively work your way through the problem is never going to work. So again, you just got to write these vectors and do these cross products, look at the results, and see if they make some sense.